One way to start thinking about fractions is to think about numbers being stretched out along a line called a number line. With each mark along the line moving from left to right, our numbers increase. So on this line behind me, the marks that I have here so far represent an increase of 1. So all of our hash marks here represent whole numbers, 0, 1, 2, and we would say that the line pictured here increases by 1 from 0 to 2. Now, if we take this same line stretching from 0 to 2 and we add hash marks in between our whole numbers, we need numbers now to represent these new numbers in between our whole numbers. And this is where fractions become necessary. Fractions are a way of representing numbers in between whole numbers. So as you can see here, I've divided each of my whole numbers into 3 parts. So I've divided them into thirds, and I'm going to write this as a fraction, thirds. I have a numerator of 1 and a denominator of 3. And the denominator represents the parts per whole. There are 3 parts per whole number. And my numerator in each of these is going to represent the part that I'm on. So let's look at it on the number line. 0 still remains 0, even when we're looking at it as a fraction. 0 thirds, or 0 over 3. This mark here then would represent 1/3. 2/3, remember we're increasing from left to right, and here at the whole number 1, we're at 3/3. Remember that any number over itself equals 1, or 3 divided by 3 equals 1. At this mark here, moving into the numbers between 1 and 2, we're at 4/3. Here we're at 5/3. And lastly, when we get here to our whole number 2, we are at 6/3. And you can see that 6 divided by 3 equals 2. So when we reach the whole number 2 and we're at the fraction 6/3, these are the same number, the same value. Let's take a look at a couple more number lines in addition to our number line that we've already looked at that's broken into thirds. So in our first number line, which all of our whole numbers were broken into thirds, we landed on our whole numbers in multiples of 3. And so our 1 is 3 over 3. Our whole number 2 is equivalent to 6 over 3. If we kept on going up to the whole number 3, we'd be at 9 over 3, or 9/3. And this works no matter how small of divisions you make between your whole numbers. In this second number line, I still have my 0 here, my whole number 1 here, my whole number 2 here. But in this case, in this number line, I've divided my whole numbers into 4 parts. And so my fractions are going to be over 4. So at my 0, I'm still going to be at 0 over 4. But at my first little mark here, I'm going to be at 1 over 4, or 1/4. At my second mark here, I'm going to be at 2/4. And my third mark at 3/4. Now, as you can see, when we land on our whole number 1, we are at 4/4. And again, any number over itself equals 1. This next marking here is at 5/4, 6/4, 7/4, and when we land on our whole number 2, we are at 8/4, or 8 divided by 4. The same case would be true here if we took our number line going from 0 to 1 to 2 and divided those spaces, or those whole numbers, into 6ths. So if I made my little divisions here and each of these was 1/6, then the same thing would happen here, and I would be able to count up from 0 to 1/6, 2/6, 3/6, 4/6, 5/6. I would land at my whole number 1 at 6/6, 7/6, 8/6, 9/6, 10, 11, and finally at my whole number 2 I would be at 12/6, or 12 divided by 6, which equals the whole number 2.